This video is for lesson 22-3 about using trigonometric ratios. Learning goals are to use the three trig ratios that we defined yesterday to find unknown side lengths in right triangles and to solve some real-world problems using trigonometry. Let's go to question 1 and practice the trigonometry from the last lesson. We have a right triangle with some numbers. We're asked for the sine of 41 degrees. So we want to look at the 41-degree angle. That's this one here, angle P. The sine function from the definitions yesterday are opposite divided by hypotenuse. The side that's opposite from the 41-degree angle has the variable y written on it. And the hypotenuse of this triangle has the 100 written on it. So we create the equation sine of 41 degrees equals y over 100. In the second question, we're asked for the cosine of 28 degrees. This is telling us to focus on the acute angle that has the 28 degrees in it, and that's angle O. Cosine is adjacent divided by hypotenuse. So if we focus our attention on this angle here, what's adjacent to the angle? It's the 18. And what's the hypotenuse? It's the side with the letter y. This is another equation that has trigonometry in it. Cosine of 28 degrees equals the fraction 18 over y. Now that we can make equations that have trigonometry, let's solve those kinds of equations. Go to number 2. Here we have a right triangle called ABC. Opposite from the 90-degree angle is the side with the 15 on it. This is the hypotenuse. The other two sides are called legs. Now one of the acute angles has the measurement 20 degrees in it. So let's focus our attention on that acute angle and look at the sides of the triangle relative to that angle. Across the triangle, the side with the x would be opposite. Which trig function involves opposite and hypotenuse? That's sine. So we write sine and then put the angle measurement, 20 degrees. Say equals and put the ratio. Sine is opposite over hypotenuse, so we write x over 15. Here's an equation that has trigonometry in it. We can solve the equation for x by multiplying both sides by 15. When these 15s cross out, the letter x is alone. Now, take your calculator and multiply 15 times the sine of 20 and push enter. To one decimal place, this is 5.1. We're able to find how long this side of the triangle is using trigonometry. Let's go to question 3 and try another one of these. Here we have a right triangle. One of the sides has a 12 on it, and the long diagonal one, called the hypotenuse, is unknown. It only has the variable y. Can we figure out how long that is? Focus your attention on one of the acute angles that actually has a measurement. So look here where the 10-degree angle is. The side of the triangle with the 12 is adjacent. The side with the y is the hypotenuse. Which trig function involves adjacent and hypotenuse? That's cosine. Now write the angle measurement, 10 degrees, and then equals. Now create the ratio for cosine. It is 12 over y. This is an equation with trigonometry, and we can solve this equation for y. Here's what the work would look like. First, multiply both sides by y. These y's cross out, leaving the 12. Then, divide both sides by the cosine of 10. When these cross out, notice that the letter y is alone on the left side of the equation. Now you can take your calculator and type 12 divide cosine 10 and push enter. This is 12.2. We were able to find out how long a side of the right triangle was using trigonometry. Let's do the same thing, but in a real-world context. Somebody named Tricia is working at a job fair, and she's going to put a ladder against the wall to hang a banner. She leans a 12-foot ladder against the wall, and the ladder makes an angle of 75 degrees with the floor. How high up the wall does the ladder reach? Let's draw a picture of this. From the side, a wall is a vertical line. The floor is a horizontal line. And the wall and the floor intersect at a 90-degree angle. From the side, this ladder is leaning diagonally against the wall, like this. Now, if you want to make the ladder look a little more realistic, you can try to give it a little bit of three-dimensional illusion where you can actually see the rungs on the ladder. That's not necessary to do that, but you can if you want a better picture. Now let's do some labeling. The ladder is 12 feet long, so which side of the right triangle do you put 12 feet on? You write it here where the ladder is. We're told that the ladder makes an angle of 75 degrees with the floor. So I'm going to label this bottom acute angle 75 degrees. How high up the wall does the ladder reach? We don't know, so we might call that x. We can find that number using trigonometry. Focus your attention on the 75-degree angle. What side of the triangle has the x on it? It's opposite. What side is the 12? It's the hypotenuse. Now decide which of the three trig functions is appropriate. Which one uses opposite and hypotenuse? That's sine. Then write the angle measure, then equals, and then the ratio, x over 12. This creates an equation with trigonometry. We can solve this for x by multiplying both sides by 12. When the 12s cross out, the letter x is alone. Take your calculator and go 12 times sine of 75 degrees. The answer is 11.6 feet. Because we're doing a real-world problem, it's important to include the unit of measure with the answer. So the ladder is 12 feet long, but because it's leaning diagonally, it does not reach 12 feet up the wall, only 11.6 feet up the wall. Next, go to the check your understanding area, and let's do number 5. We have a right triangle. Notice that one side is 16 feet. We know one of the acute angles measures 25 degrees. We do not know the other two sides of the triangle. What we're asked is, how long is the hypotenuse? We can find this answer using trigonometry. Focus your attention on the acute angle that you know the measure of. That's this one here, the 25 degrees, the angle E. Look there. We're basing everything from this position. What side has the 16 on it? It's the adjacent. What side are we asked to figure out? The hypotenuse. We don't know what it is, so we might call it x. Now, which trig function uses adjacent and hypotenuse? That's cosine. What do you write after the trig function? You put the angle measurement, then an equals. What do you put in this spot? You put the ratio. Cosine is adjacent over hypotenuse, 16 over x. Now we can solve this equation for x. The work would look like this. Multiply both sides by x so that these x's cross out. Then divide by the cosine of 25. These cancel out, leaving the letter x alone at the front. Take your calculator, type 16 divided by cosine of 25. The answer is 17.6. Do we need a unit of measure? Well, in the picture, this is measured in feet, and so we do need to say feet. So in this lesson, we used trigonometry to find unknown side lengths of a triangle. In previous lessons, we could figure out an unknown side of a right triangle using the Pythagorean theorem, but only if we knew the other two sides. Now we're able to find an unknown side in the triangle by knowing only one side, but we have to know one of the angles also. Then we can use trigonometry.